Introduction to Large Language Models. Definition and significance. Definition: Large language models, LLMs, are sophisticated artificial intelligence models capable of understanding, generating, and processing human language at scale. These models are typically trained on vast amounts of text data, enabling them to learn complex linguistic patterns and structures. Significance: LLMs have revolutionized natural language processing (NLP) tasks by achieving state-of-the-art performance across various applications, including text generation, translation, question answering, and sentiment analysis. They play a crucial role in advancing human-computer interaction, powering virtual assistants, chatbots, and language-based applications. LLMs have profound implications for industries such as healthcare, finance, education, and entertainment, where language understanding and generation are essential. Historical overview. Early language models. Early language models, such as n-gram models and hidden Markov models, HMs, laid the foundation for statistical language modeling. These models had limitations in capturing long-range dependencies and contextual information in language. Transformer architecture. The transformer architecture, introduced in the paper Attention is All You Need by Vaswani et al. 2017, revolutionized language modeling. Transformers utilize self-attention mechanisms to capture global dependencies and context, enabling efficient parallelization and scalability. Emergence of large language models. Breakthroughs in hardware capabilities, data availability, and algorithmic advancements led to the development of large-scale language models such as GPT, Generative Pre-trained Transformer Series by OpenAI and BERT, Bidirectional Encoder Representations from Transformers, by Google. These models, with billions or even trillions of parameters, have significantly improved the quality and performance of language understanding and generation tasks. Recent developments. Recent advancements in LLM research focus on improving model efficiency, interpretability, and robustness. Techniques such as model distillation, sparse attention mechanisms, and ethical considerations are gaining attention in the LLM community. Impact on society. While LLMs offer tremendous potential, they also raise concerns about biases, misinformation, privacy, and ethical use. Understanding the societal impact of LLMs is crucial for responsible deployment and regulation in various domains.